Okay, so it was such a beautiful clear night last night, the first one in ages, that I couldn't resist getting the eVscope out and just seeing how far I could push things with it. So here's the result of my labours. It's a remarkably unprepossessing looking bit of sky, as you can see. It's about 2 hours of integration on this patch of sky. The bit I was actually interested in is down here. If I push the contrast on the image a bit, maybe you can start to see what it was I was looking for. You can see there's a bunch of little faint blurry things here. Just for the moment, just hold in your mind this pattern of 5 stars up here, because they'll be a kind of useful reference point for what I'm about to show you. So what was it I was looking here? Let me show you a rather better image of the same patch of sky taken with a much bigger telescope. And there's that pattern of 5 stars again. You can see it's a different way up. Now we've got the more traditional kind of north at the top astronomical image, but there's that pattern of 5 stars. This is the patch of sky I was looking at. And when you look in here, you can see there are indeed a smattering, a whole bunch of galaxies, one there, one there, one there, a few other little faint ones in between. And if I put my image over the top, you can see that actually it was capturing at least those 2 brighter galaxies and 1 or 2 of the intermediate brightness ones as well. If I just flick backwards and forwards between them, you can see that actually even with my little 4.5-inch eVscope, I was picking up some of these galaxies. Now they're very, very faint. That's not so surprising because this particular collection of galaxies is about 3 billion light years away. So not surprisingly, they're really rather faint on the sky, so it's impressive that we can see them at all. But what I wanted to show you was not the optical image of these things, but what happens if you point an X-ray telescope at it. And this is some work done by my colleague Helen Russell at the University of Nottingham with the Chandra telescope, X-ray telescope. And what you're seeing here is the X-ray image superimposed on the optical data we were looking at before. And you can see there is this plume of X-ray emission. Remember, the X-ray emission here is coming from very hot gas, so there's very energetic processes, gas at many millions of degrees. And you're seeing emission from that gas, but it's not nice and uniform and relaxed. You can see it's very, very disturbed. There's all these structures in it. There's a bright patch here. There's these plumes, extended X-ray emissions spread out over a large area of the sky. And what Helen was able to do was study this system in detail and actually really understand what's going on in it. And in fact, what you're seeing here is not 1 cluster, but 2 clusters. And one of them has just smashed through the middle of the other. And you're kind of seeing the carnage of that collision, the way the gas is heated up, shocks form, material is thrown, gas is thrown out in all directions. And so that's the structure that you're seeing here. So that's what you're seeing from my back garden. I think it's kind of amazing that this rather faint patch of sky here is actually an incredibly energetic event of 2 massive clusters of galaxies smashing into each other some 3 billion years ago, because it is 3 billion light years away. And we're seeing the light from those colliding clusters of galaxies arriving in my back garden last night.